Today we are going to see about special function devices. In that we are going to see UJT, SCR, diac and triac. First we are going to see about UJT, unipolar junction transistor. This is unipolar junction transistor. This is a normal diagram of this. Next, in this construction, UJT construction, the UJT consists of an N-type silicon semiconductor board with electrical connections at each end. The terminals of these connections are called base terminals, that is B1 and B2. Near base B2, a PN junction forms between a P-type emitter and N-type silicon board. The terminal of this junction is called the emitter terminal. The terminal near the B2 is called the emitter terminal. Since the device has 3 terminals and one PN junction, it is called the unijunction transistor. Only one junction, that's why it's called as unijunction transistor. The emitter is heavily doped while the N region is slightly doped. Emitter is a P-type material, N region is a N-type material, that is slightly doped material. 3-terminal device. UJT has 3 terminals, emitter, base 1, base 2. This is a voltage controlled switch. It acts as a switch turning on or off based on the input voltage at the emitter. Negative resistance. In breakdown mode, UJT exhibits negative resistance, making it useful for relaxation oscillator. Single PN junction. UJT has only one PN junction, simplified structure. It has only one PN junction. VI characteristics of UJT. Cutoff region. Initially, a light leakage current flows as VE increase from 0 due to minority carriers in the reverse biased diode. Forward conduction. Beyond a certain VE value, forward current starts flowing, reaching a peak voltage and current IP at that point. Negative resistance region. Further increasing VE leads to suddenly the current value will be reduced. After the peak point, the region will be negative resistance region because the voltage increases, the current value increases, the value will be 0. Saturation and valley point. The negative curve continues until valley point V. At V, the device enters the saturation. After the V, the device enters to the saturation region. This is the characteristics diagram of UJT. Next, we are going to see about SCR. SCR. This is the construction of SCR. This is a symbol of SCR. It has 3 PN junctions. SCR consists of 4 layers, PN semiconductor material. It has 3 junctions, J1, J2, J3. The terminals are anode, cathode and gate. Anode connected to the outer P-type layer. Cathode connected to the outer N-type layer. Gate attached to the P-type layer near the cathode. It combines an ordinary rectifier and a PN junction and a junction transistor. Ordinary rectifier and junction transistor in a single unit. SCR acts as a rectifier and a transistor. Functionality. Combines MOSFET and BJT features. High input impedance like a MOSFET for EC gate control. Low on-state resistance like BJT for efficient current conduction. Handles high voltage and currents as a voltage control switch. Faster switching speeds compared to traditional BJTs. VI characteristics. Low voltage, high impedance region. In this stage, the SCR behaves like an open switch, allowing minimal current flow. The voltage is low and the impedance is high. High voltage, low impedance region. When the voltage surpasses the breakover voltage, a rapid increase in current occurs, indicating the SCR transistor to the conducting state. Next, diac. Diode for alternating current. Diac is a diode for alternating current. It is a two terminal device that is labeled as MT1, MT2. Symmetrical structure. It has a symmetrical structure with the 5-layered configuration, typically PNP or NPN, depending on the manufacturing process. No gate terminal. Unlike other thyristors, diodes do not have a gate terminal. They are triggered by the voltage applied across the terminals. Bidirectional switch. It can conduct current in both directions. Once the breakover voltage is exceeded, functionality. Symmetrical semiconductor. It is a two-terminal device with a balanced design. Trigger functionality. A switch that can trigger in both directions. Impedance characteristics. So high resistance under both forward and reverse conditions until reaching a predetermined voltage threshold. A characteristics. Symmetrical switching. The diac includes symmetrical switching characteristics for either polarity of an applied voltage, resembling the English letter Z. Trigger voltage. It remains non-conductive until the applied voltage exceeds the trigger or breakover voltage. Conduction state. Once the breakover voltage is reached, the diac starts conducting and the current through the device increases while the voltage across it decreases. Bidirectional conductivity. The diac can conduct current in both and forward and reverse direction once the breakover voltage is reached for both positive and negative half cycles of an AC voltage. Next, triode for alternating current. Three-terminal device. In this we are having MT1, MT2 and gate. Four-layered structure. Four-layered semiconductor structure with alternating PN material. Bidirectional conductivity. When triggered, the device can conduct current in both directions, making it suitable for AC applications. Gate triggering. The gate terminal is connected to both P and N regions, triggering the triac by both positive and negative gate signals. Functionality. Bidirectional control. When triggered, the triac can control AC power with allowing current to flow in both directions. Gate triggering. It can turned on by applying a gate voltage higher than the breakover voltage or by gate pulse. 4 operation mode. It has 4 operation mode depending on the polarity of MT2 and MT1. Once triggered, a triac remains on without gate voltage until the main terminal current drops below a certain level. VA characteristics. Bidirectional conduction triac allow current to flow both directions. Functionality is similarly to two SCRs connected anti-parallel. 4 operational modes. They operate in 4 quarters, each representing various voltage polarities and gate triggering combinations. Gate sensitivity. The breakdown voltage decreases with an increase in gate current, which can be positive or negative. Blocking and conducting state. Triac exhibits a blocking state until the breakover voltage is reached, after which they enter the conduction state and allow current to flow.